We're going to talk about function notation. A linear function we know can be written in the form y equals mx plus b. But if we name our linear function f, we can also write the function in what is called function notation. So in function notation, instead of y, I'm using f of x, saying the function when the input is x equals mx plus b. So the notation f of x is another name for y. If f is the function and x is its domain, then f of x actually represents the output that corresponds to the input of x. You can use other letters to name your function, so you could have g or h, so we could have g of x or h of x. Let's see some examples where we're using function notation. So here we're being asked to evaluate f of x when it equals negative 4x plus 7, when x is 2 and x is negative 2. So first let's start with our function f of x equals negative 4x plus 7, and first we're going to plug in the input of 2. So when the function has an input of 2, it equals negative 4 times 2 plus 7. So negative 4 times 2 gives us negative 8, plus 7 gives us negative 1. So when x equals 2, f of x equals negative 1. So basically we're saying when our input is 2, our output is negative 1. So let's look at another example of this. So this time our input is going to be negative 2. We have the same function, f of x equals negative 4x plus 7, except this time for our input we're going to be putting in negative 2. And that will make this guy negative 4 times negative 2 plus 7. So when my function has an input of negative 2, I can start solving. Negative 4 times negative 2 gives me 8 plus 7. So the function when the input is negative 2 equals 15. So basically when x equals negative 2, when negative 2 is our input, our output is 15. So let's look at a real life problem where we're using function notation. So let's say that we have f of t, and we're going to let that be the outside temperature in degrees Fahrenheit t hours after 6 a.m. So t represents the hours past 6 a.m. F of t represents the temperature outside. They want us to explain the meaning of each statement here. So if I have f of 0 equals 58, that's 0 hours past 6 a.m. So that is exactly 6 a.m. That's our initial temperature. So the temperature at 6 a.m. it's saying here is 58 degrees Fahrenheit. Here it's saying f of 6 equals n. So this would be 6 hours past 6 a.m. So 6 hours after 6 a.m. would actually be noon. And so they're telling us at noon, it's n degrees Fahrenheit. They could have been more specific here and given us a value for the temperature, but they didn't, so we're just calling it n degrees Fahrenheit. Here we have f of 3 is less than f of 9. So they're basically telling us that the temperature at 9 a.m., 9 a.m. is 3 hours after 6 a.m., is less than the temperature at 3 p.m. 3 p.m. would be 9 hours after 6 a.m. We can also use function notation to solve for an independent variable. So in this case, we're given an equation, h of x equals 2/3 x minus 5. And they want us to find the value of x, that independent variable, when h of x equals negative 7. So for h of x, I'm plugging in negative 7. So I have negative 7 equals 2/3 x minus 5. So the first thing I did here was add 5 to each side so that this would cancel out here and I'd be left with negative 2 equals 2/3 x. Now to get rid of the 2/3 here, I'm multiplying by my reciprocal, 3 over 2 on both sides. So here it cancels out and I'm left with x equals -3. So my x value here is -3. That gives us an output of -7. So let's try another. This time we have g of x equals 6x plus 9, and they want us to find the value of x for which g of x is 21. So we're given the output value of 21, and we are asked to find the input value, or the independent variable. So I'm going to start here by subtracting 9 from each side. So cancel out here, and I'm left with 6x. And on this side, I'm going to have 12. I'll divide each side by 6, and I get a value of 2. So my input value is 2, and it gives us an output value here of 21. Let's say we're asked to graph something in function notation. So they asked us to graph f of x equals 2x plus 5. Well, the first thing we're going to have to do is make an input-output table so we can find some ordered pairs that fit in this function equation. So I've already picked some input values to test here. So let's try plugging in -2. So 2 times -2 is -4, plus 5 would give us an output of 1. Let's put in -1. 2 times -1 is -2, plus 5 would give us an output of 3. If we plug in 0, 2 times 0 is 0, plus 5 is 5. If we plug in 1, 2 times 1 is 2, plus 5 is 7. And if we plug in 2, 2 times 2 is 4, plus 5 is 9. Once we have our input-output table filled out with some ordered pairs, we can plot the ordered pairs. That is step 2. So I'm going to start with -2, 1, -1, 3, 0, 5, 1, 7, and 2, 9. And the last thing we're going to do is we're going to actually draw a line through our points.